All right, so not a whole lot for me to write on this one because I've got stuff popping up, but we're starting chapter 8 and we're talking about exponential models, whereas we've been dealing with a lot of powers like x to the fifth or 6 to the third power, something like that. Now we're going to have x as the power. So like 2 to that power, or like 1/2 to that power. So that's what's going to be different here. All right, so this is just some information. If you want to read it, you can. I'm going to get into the nitty gritty here in a little bit, though. Here we go. So we're starting off by graphing. Now, you guys might not have graphs at home. That's fine. I don't require that. What I do require is you to copy down the XY table. You got to have the table if you want full credit for this assignment. So this is technically, if you want to call it, we'll call it number 1. Okay, we're going to graph this best we can. So I'm going to start with -2. What that means is we take 3 to the -2nd power. Okay, what that looks like is 1/3 squared, which would be 1/9. Now, you would then have to plot the point -2, 1/9. We haven't done a lot of graphing this semester, so we go to the left 2 and up 1/9. So it'll pop up right around there, if you will. Okay. And that's where it is. Now, the next one's -1. So we take 3 to the -1st power, put the x value where it goes, which is the exponent on 3. So this will be 1/3. So just 1/3. So then that's going to be at -1, 1/3, which is right about there. Could be better, could be worse, but that's where we're going to put it. Then we have 0. Now, this is a good one. Hopefully you remember this. You take 3 to the 0 power. Now, anything to the 0 power, almost anything anyway, is going to be just 1. So then 0, 1, that's a good location to have on a graph. It's right there. All right, if you can't see that very well, try and highlight it here. Right there. So we have 3 points so far. Next, we're going to plug in 1. When you plug in 1, that's just 3 to the 1st power, which is just 3. So 1, 3. And then last but not least, we plug in 2. Now 2 would be 3 to the 2nd power, 3 to the 2nd power, not 6, it's 9, because 3 squared is 9. So then we plug in those points. And we'll connect the dots with what's called an exponential curve right there. So connect the dots in a roundabout way. If you can graph, I say go for it, but I'm really needing you to have this down. By all means, have that as well. Okay. This is called exponential growth. And hopefully you know why. It's because it's growing. As it gets bigger and bigger and bigger and bigger and bigger. All right. Now, a couple things moving forward. This one has an asymptote. That's where the graph does not touch. Right here. All right, it doesn't touch there. So x equals 0. Sorry, y equals 0, or the x-axis would be an asymptote to this. Okay. Now, you can plug any number in. So the domain is all reals. But you're only going to get positive numbers out. It's never going to actually get 0 because 3 to any power cannot be 0. So, got to have the table. This is exponential growth, and it's exponential growth because the number being taken to the power, this number right here, is bigger than 1. Since 3 is greater than 1, okay, that's what makes it exponential growth. Now, this is going to be exponential decay. This number right here is less than 1 but bigger than 0. So that's why this one's going to be decay. Now, this is a different example because we have a 2 in front of it, so that's going to be okay, but there's just a little bit more work to do. So we're going to plug in -2. So if you want to, the domain is always going to be, or the values that you need to have for most of these graphs are going to be -2, -1, 0, 1, and 2. Just 5 points, and you connect them. Anyway, when you plug in -2, you have this. Now, that 2 times 1/4 to the -2nd power. That -2nd power flips it. And when you flip 1/4, you get 4. Then you square it. So what's not shown here is we're going to have 2 times, what's 4 squared? 16. And 2 times 16 gives you 32. So that's going to be a problem because we can't fit that on our graph. All right, now on one of the homeworks, you're going to have enough room. But on this one, you don't for that point. So that one's just not on the graph. And that's okay. But it would be -2, it'd be up here. It'd be way up there if you're trying to figure that out. Now if we try negative 1, now this one we should be able to fit on there, or at least close. This would be 2 times 1/4 to the negative first power. Now I'm going to try and do this one by hand. So this negative first power takes that fraction inside here and flips it. So we still have the 2, but if we flip that fraction, it'd be 4 over 1, or just 4. And then it'd be the first power. Now 4 to the first power is just 4. 2 times 4 is 8. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8. So this point should be on our graph after I click through. Yep. Oh, it didn't. The point didn't pop up. Okay, I'll do it later then. Now the next point is 0. We're plugging in 0 for x. So that's going to be helpful because 1/4 to the 0 power, that's just going to be 1. So 2 times 1 is going to be 2. Okay, so 0, 2 will be where it crosses the y-axis. Then we plug in 1. So it'd be 2 times 1/4 to the first power, which would be 2/4, which would actually be 1/2. It's not a terrible point. We'll figure that one out. And then last but not least, we plug in 2, which means we take 1/4 to the second power, we square that, we get 1/16. So 2 times 1/16 is going to be 1/8. So when we are plotting these points, negative 1, 1, 2, 3, 4, 5, 6, 7, 8. This is the point, negative 1, 8. Then I have 0, 2, which is that point right here. Then I have 1, 1/2, not a bad point. And I have 2, 1/8. And so what's going to happen is it starts up here and it falls. Now, it's important if you're graphing these, ladies and gentlemen, you don't cross, with this one especially, the x-axis. All right, that's another asymptote. Our graph is not going to come down here and cross the x-axis. It can't. There's no number that you can plug in for x. It's going to make anything you get out of it negative. All right, so that's how you graph those. Okay, so we're working with exponential functions. It's probably a good idea for you, since I am attaching the notes, for you to copy some of this down. B in this, B is the growth or the decay factor. And that's what I was trying to talk about before. Whenever B is greater than 1, it's going to be growth. The graph will get larger and larger and larger. If B is less than 1, it also has to be greater than 0, but that'll be a decay factor, which means it starts and it goes smaller and smaller and smaller. Okay, now if we're talking about these examples, we're talking about whether it's growth or decay. This number in here is all you need to look at. Is that bigger than 1? Yeah, that means it is growth. It represents exponential growth. Now, on number 2, 0.65, that's less than 1, so that would be exponential decay. Number 3, 3/4 is less than 1, so that would be another example of decay. And then for number 4, 9/2, same thing as 4.5, so 9 divided by 2 is 4.5. Yeah, it's going to be growth. It's getting larger. And that's all you have to know about those. Now, these next 2 examples, ladies and gentlemen, are going to be very helpful, or it's going to be helpful if you have an XY table. So I'm going to try and do my XY table over here on the side and show you exactly what you're going to need to have to get full credit on these, because it's going to be difficult for some of you to graph, but it's not difficult for you to have a table. So you have to have the table if you want points. So we're going to start with negative 2, negative 1, 0, 1, and 2. Negative 2, negative 1, 0, 1, and 2. Now, this is an example of growth because, 2 is bigger than 1. And this would be an example of decay because 1/3 is less than 1. So I'm going to do a little bit of math here. Forgive me. So we're going to start with negative 2. So if you have 2 to the negative second power, the same thing as 1 over 2 squared, which would be 1/4. So you put 1/4 right in there. Done. All right. Next up, we have 2 to the negative first power, which is 1 over 2, which is just 1/2. That one's done. You have 2 to the 0 power. That's going to be 1 always. And then you have 1 when you plug it in. 2 to the first power is just 2. 2 to the second power is going to be 4. So then we're graphing these. We have negative 2, 1/4, so somewhere down in there. Then I have negative 1, 1/2, so a little higher. 0, 1, boom. 1, 2, yes. And then 2, 4, yes. Now there's another point you could plug in here, 3. If you plug in 3, it's 2 to the third power. It's going to be 8. 3 to the 8th power, or sorry, 3 comma 8. And then we're going to connect these very carefully, starting somewhere right in here and going. Yeah, I had to download the sound effects. Okay, so that one's in. That's done. It's fully graphed. Every point that we could fit on the graph is graphed. Now, next up, we have 1/3. We're going to take that to the -2nd power, which means we flip it. So this would be 3 to the 2nd power, and 3 to the 2nd power is 9. So -2, 9 is our first point in there. It's -2, 9. Then if we try -1. All right, so -1. That just means we flip it. So it's just it's just 3 over 1. It's just 3. -1, 3. Then, if we take it to the 0 power, that's going to be 1. And then if we take it to the 1st power, that's just going to stay 1/3. And then if we take it to the 2nd power, we get 1/3 squared, so 1/9. It's going to be closer and closer, but not yet quite to 0. So then we connect those dots like this. All right, should be good. Thank you.